Okay, so this is a revision video for today's lecture. Okay, so we have discussed about how to identify vector and scalar in the previous video and how can we use this vector thing to describe motion in a plane. Okay, now we are going to see two important rules for vector, that is multiplication rule for the vector and addition and subtraction rule for the vector. Okay, first is multiplication rule for the vector. It's very simple that whenever you add any real number, real means minus infinity to any plus infinity, any value between this thing, you can add with the vector. Okay, and what are the impact on this vector, what are the impact on the magnitude part of the vector and direction part of this vector when we multiply real number, whether plus real number or minus real number, whether it is any impact on the magnitude and direction part of the vector. Let's see the multiplication rule for the vector. Okay, now multiplication rule is very simple. Multiplication rule for vector. Okay, suppose I am having some unknown vector, let's say a, and if I multiply this vector a by 2, okay, that is the real number, 2 is real number, what will happen, that this 2 will have impact on magnitude of A. That is, by multiplying 2 with the vector A, the magnitude part of the vector A will get double. For example, if this A is equal to 10, okay, if I multiply this 2 with 10, I will be getting an answer that is 20. So if the magnitude has changed, the length of the vector will also change. So now the new length of the vector will be 20. Okay, you can easily see the length has been doubled by multiplying with the real number. Okay, so now we will be going to see what is the impact if we multiply this a vector with the negative real number. Okay, negative real number. For example, if I take -1, if I multiply a with -1, what is going to happen? The answer is simple. The answer is simple, that now the impact will be only in the direction of the vector. Impact will be only in the direction part of the vector. Okay, so on multiplying with minus sign, on multiplying with minus, my vector direction will be opposite to the previous one. Okay, to the previous one. So one thing is very clear, this minus sign will take care of direction and this real number will take care of magnitude. Okay, this is multiplication rule. It's very simple. Okay, now we are going to see one more important rule of the vector addition, that is triangle law of addition. Okay, triangle law is very simple. Okay, but why we are using this addition? See, because scalar plus scalar can be added like algebraic sum. For example, you can add mass equal to 2 kg and mass equal to 3 kg. You can add mass plus mass because they are scalar quantity and they can be added just like the algebraic summation of any other number. So the total mass will be easily, we are getting as 5 kg. But can we add vector like this? Difficult? No, it's not difficult, it's very easy because scientists has made everything easy. Physicists have made everything easy. For example, if I am having two forces like this, if they are pointing in the same direction, then the total force will be F1 plus F2. Okay, it was easy. It was easiest than easy. Okay, but what? But what if? But what if they are acting in different direction? Now, can you add F1 plus F2 like the algebraic summation that we have done previously? No, we cannot add that thing. So for that, we require triangle law of vector addition. This is very simple. You have to just remember one thing, and that one thing is that for the addition, the tail, this part is called tail, and this part is called head. The tail should be connected. The tail part should connect with the head part of the another vector. Let us connect it. Okay. Now the third side of this triangle will give us the resultant. Will give us the resultant. Okay, it's simple. It's simple. By with the help of triangle law of vector addition, we can easily find the addition of two vectors that are pointing in different direction. Okay, and one thing always keep in mind, whenever you are mentioning vector, there must be a arrow over it. There must be a arrow over it, because arrow represent that the symbol is for a vector quantity. Remember this thing? Okay. Okay, that's all for today. This is the revision part only. Okay, if you want to revise the previous video, it is already in the YouTube link of the SKIS. Okay, you can go over there and you can watch it and revise it again. Okay, thank you.